Class 8th, Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome back to your online class. I hope you are revising your chapters. I had started with solubility, factors affecting solubility in the last lecture. I had told you about solutions, suspensions and colloids and had given you the table on page number 114, 115. I had discussed this table with you, that is giving the differences between the solution, suspension and colloids. Now let us proceed on with the chapter, that is water of crystallization. Now you have come across this term so many times, the water of crystallization. So many times you have written, I have shown you that copper sulphate 0.5H2. I had shown you that this is hydrated copper sulphate, which is blue in color, which turns white on heating. It becomes anhydrous. So that is just because of the blue color, is just because of the presence of the water of crystallization. So the fixed amount of water, that is the number of water molecules which are chemically combined in a definite molecular proportion with salt in its crystalline state, is called water of crystallization, or it is called as water of hydration. Is that clear? So this is the fixed number of water molecules which are chemically combined in a definite proportion with a particular salt in its crystalline state. Is that clear? You have so many other such compounds like cobalt chloride 0.6H2, 6 water molecules attached. Then sodium carbonate the NO2CO3 0.10H2O, there are 10 water molecules attached. So there are the number of water molecules are different for different compounds. Is that clear? So this water of crystallization is also called as water of hydration, and the salts that contain water of crystallization, they are known as hydrated salts. HYDRATED, hydrated salt, they contain water of crystallization. Is that clear? Now this water of crystallization is represented as 0.6H2O, 0.5H2O. This is loosely held with the substance. The attachment with the crystal is loose. Thus, when any substance is heated, this water of crystallization can easily be removed. It is easily lost, and the crystalline form also gets lost, as you have seen when we had heated copper sulphate, which is blue in color, and when it is heated, it changes into white anhydrous copper sulphate. Is that clear? So this is just because of the loss of 5 molecules of water of crystallization which were combined with copper sulphate in its crystalline form. Is it clear? Now you can see over here, this copper sulphate is blue in color, crystalline copper sulphate CuSO4 0.5H2O. Is that clear? This is blue in color, and when it is heated, it changes to white anhydrous form, which is just a white amorphous powder. Amorphous means non-crystalline powder. Is it clear? So in simple terms, you can write it in the form of an equation. You can write it that when copper sulphate, hydrated copper sulphate, which is blue in color, is heated, it changes into the anhydrous copper sulphate, white in color, and water of crystallization is removed. Is that clear? So anhydrous copper sulphate turns blue as soon as we add water to it. So this is shown in the activity 4 on page number 116. So here you can see this is hydrated copper sulphate. You can see the blue color. Is that clear? This is crystalline blue copper sulphate. Now to remove the water of crystallization, we heat the crystals. You can see the crucible which is placed on the wire gauze on a tripod stand, under which there is a burner, and we heat it. You can see the crystalline form of this, and when we heat it, you will see how the water of crystallization gets lost. You can see this crystalline form, isn't it? Now what happens, the thermal decomposition also, you can see the blue color changing to white. This is the loss of water of crystallization. Is it clear? Now this is anhydrous copper sulphate, it's changed to blue and adding water, it becomes hydrated. So we can conclude that on heating the copper sulphate crystal, they lose water of crystallization and turn into an anhydrous white copper sulphate, anhydrous white powder. On adding water, the blue color reappears due to the addition of water of crystallization. Is that clear? Then what is a crystal? Now what can you see in this? You can see various crystals, various kinds of crystals. Is that clear? So you can see these have a different geometrical pattern, and that is similarly with all many crystalline compounds, whether you are studying about copper sulphate, sodium carbonate, if you see under the microscope, they will have a well defined geometrical pattern. Is that clear? That will appear in the form of a 3-dimensional structure. So a crystal or crystalline solid is what it is, a solid material whose constituents such as atom, molecules, ions, they arrange in an ordered microscopic structure, well defined geometrical pattern is there. Is that clear? And this scientific study of crystals and crystal formation is known as crystallography, and the process by which crystals of a substance are obtained by cooling its hot saturated solution, as I had shown you, this is called as crystallization. Is it clear? So that is when we had added more and more sugar to a particular saturated solution and kept on heating, and when it cooled it, it changed into crystals of sugar again. So similarly here also, when we take a particular substance and we make a hot saturated solution and then let it cool, it forms crystals of that particular substance, that particular compound. So, and on the basis of presence of water of crystallization, I have shown you that how hydrated and anhydrous compounds are formed. So, I earlier told you that the substances that contain water of crystallization, they are called as hydrated. Example, hydrated copper sulphate, then similarly hydrated ferrous sulphate and Epsom salt are examples of hydrated substances. Similarly, substances that do not contain water of crystallization, they are known as anhydrous substances. Example, common salt you have at home, it is anhydrous substance, and potassium nitrate, they are examples of anhydrous salts. Is it clear? Then there is one more phenomena which is related with this, that is the phenomena through which some hydrated crystalline substances, they lose the water of crystallization partly or completely on exposure to dry hair. This is called as efflorescence. For example, if you leave water washing soda, it will lose its water of crystallization and change into an amorphous substance. Is that clear? So such substances are called as efflorescent substances. The loss of crystallization from the hydrated substances into the atmosphere, so that an equilibrium is formed between the hydrated substances and the surrounding atmosphere. Is that clear? So we can show it like this. So this is washing soda, that is sodium carbonate, 0.10H2O is the formula, formed by combination of sodium carbonate and 10 molecules of water forming sodium carbonate decahydrate. Is that clear? It is the chemical name of washing soda, and when it is heated, it loses this water of crystallization. Is that clear? When exposed to air. So sodium carbonate 0.10H2O, or you can say sodium carbonate decahydrate loses its all the 10 water of crystallization molecules of water when exposed to air. Similarly, and sometimes sodium carbonate loses 9 of its molecules of water of crystallization when exposed to air. Is that clear? Sodium sulphate, that is Globasol. Please change in your book, it is sodium sulphate, not sodium carbonate. Sodium carbonate loses all its water of crystallization when exposed to air, while Glauber's salt, that is sodium sulphate 0.10 H2O, loses 9 out of 10 water molecule when exposed to air. Is that clear? So, it loses 9 and 1 is left. So, the phenomena through which some hydrated crystalline substance, they lose their water of crystallization partly or completely. This is partly, one part is still left, but here all the 10 molecules are lost. Is that clear? 0.10 H2. So, this is efflorescence. Now, deliquescence is a reverse of efflorescence. The phenomenon there is another phenomena, deliquescence, which is reverse of efflorescence. So, what is it? That it is a process or phenomena through which some crystalline substances, they are when they are exposed to the atmosphere at ordinary temperature, they absorb the moisture from the air instead of losing the water. Is that clear? Losing the water of crystallization. They become moist and they lose their crystalline form, and they get dissolved in water to form a solution. This is called as deliquescence. Is that clear? So, in efflorescence you had seen they lose the water of crystallization partly or completely, and they become anhydrous. And here you see they are absorbing extra moisture, and they are losing the crystalline form, and they are getting dissolved in water to form a solution. This is called as deliquescent, and such substances are known as deliquescent substances. So, the examples of deliquescent substances are ferric chlorides, caustic soda and calcium chloride. So, here you can see sodium hydroxide or caustic soda is deliquescent and loses its crystalline form, and slowly it changes into solution of sodium chloride. And similarly, we have other deliquescent substances, that is ferric chloride and calcium chloride. So, the tendency of certain substances to absorb water vapor from the atmosphere when they are exposed to it without getting changed into liquid solution is known as hygroscopy. Hygroscopy, the phenomena is known as hygroscopy, and the substances which are undergoing hygroscopy is are known as hygroscopic. So, what is the difference between the deliquescent substances and the hygroscopic substances? Deliquescent substances change into solution, while the hygroscopic substances do not change their form, they remain as such. You even do not get to know that moisture is being absorbed. So, such substances are used as drying agents. Is that clear? So, some of such substances are concentrated sulfuric acid. So, concentrated sulfuric acid is an example of hygroscopic substance. Another example is phosphorus pentoxide. Then we have examples as quicklime, anhydrous calcium chloride and silica gel. They are all used as drying agents, where particular substances are required to be dry, but they absorb moisture from the air. So, we generally use certain drying agents for them and to remove the water from them. So, the most commonly used drying agent is silica gel pouches, which we keep in unused water bottles or even in camera lenses. Is it clear? So, you can see these pouches are kept in the container in which the box in which the camera lenses are kept, in order to avoid or prevent the absorption of moisture. And they also kept in the water bottles, these silica gels pouches, so that the moisture is absorbed. Next is the chemical properties of water. Now, pure water is neutral in nature. It has no effect on litmus solution, as you can see. In litmus solution or litmus paper, both blue and red litmus, they are showing no effect. No, blue is not changing to red, or no, red is changing to blue. That shows water is neutral in nature. Is that clear? It is neither acidic nor basic. Now, I have discussed this point when we were discussing about the electrolysis, that pure water is a stable compound. It is absolutely impossible to decompose it by heating, at ordinary temperature, or by simple physical methods, or by reacting it by certain chemical agents. But generally it is decomposed into hydrogen and oxygen when temperature is raised above 2000 degrees Celsius, or when it is electrolyzed. We have seen this setup earlier also. So this is used to decompose water, split up water into its constituents, that is into hydrogen and oxygen. Yes, this is not a new equation for you. So this can be done when water is heated above 2000 degrees Celsius or it is electrolyzed, that is the decomposition of a chemical substance in its aqueous form by the passage of electric current. So water can be split up or it can be decomposed by the passage of electric current, by electrolysis, or by raising the temperature above 2000 degrees Celsius. Is it clear? So we can say that pure water is a stable compound and it does not decompose easily. It can only decompose by raising the temperature above 2000 degrees Celsius or by the process of electrolysis. Next is the reaction of water with metals. We have discussed this earlier also, that is cold water reacts with reactive metals to form metal hydroxides. As you can see, this is the reaction with sodium, and water gives sodium hydroxide and hydrogen gas. Similarly, the reaction with calcium and potassium also. The reaction takes place with cold water, although the reaction with calcium is a little slow, while those reaction with sodium and potassium, they are quite fast. Is that clear? And vigorous. Then, however, steam reacts with less reactive metals to form metal oxides and hydrogen gas. You can see here hot water or even steam reacts with magnesium and forms magnesium hydroxide and hydrogen. But generally the reaction that takes place here is magnesium oxide and hydrogen gas is evolved. Is it clear? So this is steam over here. This is steam. Similarly, the reaction that takes place with aluminum and iron also takes place with steam only, and here please change in your book. We have earlier discussed this. This takes place with hot water and the products that are formed are magnesium hydroxide and hydrogen, while the reaction with steam in the case of metal is with iron, that is taking place to form, that is iron and steam might form iron 2 ferrous oxide or ferric oxide. Is that clear? Depending upon the amount of steam that has passed. So the reaction, if you sum up, you can just write that it takes place as this one, that is 4H2O, that is this reaction that is given. This is the right one, that is, you can sum it up and put it like this, that is iron reacts with water to form iron 2 oxide, ferric oxide and hydrogen, and this is a reversible reaction. Is it clear? This is a reversible reaction. You can put the arrow like this. This is a reversible reaction. Then reaction of water with non-metals, that is on passing superheated steam over red hot coke, that is the steam which is at the temperature is in thousands over red hot coke. Then we have already discussed that is it forms a mixture of carbon monoxide and hydrogen gas, which is known as water gas, and this water gas is a good fuel. Is it clear? It is a good fuel. So you can see that carbon, when it is on passing superheated steam over red hot coke, this is red hot coke, the symbol is C. This is also a form of carbon only, and it passes over steam, then it forms a mixture of carbon monoxide and hydrogen. This is known as water gas. Then another non-metal is chlorine. Chlorine is what? It is a greenish yellow gas, and it is, when it is passed through water in the presence of diffuse sunlight, then we get a mixture of hydrochloric acid and hypochlorous acid. Hydrochloric acid HCl and hypochlorous acid HCl. I have told you that this reaction does not take place in dark, and if it is exposed to direct sunlight, then an explosion will occur. So we do it in diffuse sunlight. Is that clear? That is, the sunlight is not direct. then this hypochlorous acid which is obtained is unstable. So it eventually decomposes to further into hydrochloric acid and oxygen. So this reaction is, you can see this overall reaction can be put as chlorine and water react together to form hydrochloric acid and oxygen. So we have discussed the reaction of water with non-metals, that is carbon and chlorine. So we'll discuss the other reactions later on. Allah Hafiz.